Barb Miller-Webb. I'm with D3 Technologies, and welcome to the 20 to 30 minute webinar. As you know, these are a series of webinars that we tend to have that discuss the various technologies that are available out there in 3D printing. And certainly this is just one of the 7 different technologies that are available through 3D Systems. We also represent 3DP platform, which is another type of technology and manufacture. So I think we're going to go ahead and get started at this point. And of course, this one is on direct metal printers, talking a little bit about additive manufacturing, more specifically with the 3D Systems ProX DMP systems. And before we get started, I'm just going to give you guys a quick brief introduction for those of you that don't know D3 Technologies. We are a basically trusted advisor. We try to help manufacturing companies be more successful, and obviously at the end of the day it's all about helping those manufacturing companies increase their revenue, reduce their costs, and we try to do that through leveraging the latest engineering design technologies such as through 3D printing, 3D scanning, CNC machining, software support, services, mentoring, etc. Bottom line, our methodology is to obtain lean engineering through some of our processes, tools, technologies, and people in leadership. So without further ado, let's go ahead and move forward. Today, we're going to talk about direct metal printing. And so basically, you're able to unlock the product's potential through this fast prototyping of new design ideas with manufacturing grade alloys that really is much more powerful by revolutionizing your manufacturing approach today to make those products lighter and certainly with the higher performance maybe, and certainly customizable. This is going to be a video that I really just want to take you guys through so you can see a little bit about direct metal printing, and then I'm going to talk further about it as we get into the presentation. So I know that gave you just a little snippet of what some of the laser metal printers look like and some of the process that it uses, and I'm going to get into a little more detail with that further in this presentation. But as you guys all know, we operate in I call it a hyper-competitive world today, where innovation are really the true hallmarks of a successful organization. And additive manufacturing has been around for 30 years, as you guys know. Systems was the first to invent 3D printing with Chuck Hull, our founder, and it's obviously revolutionized to where we have today. So as we know, it really does hold the promise of fundamentally changing the nature of our manufacturing. But only recently has printing metal parts become compelling enough through enough proposition for most companies to really take notice and start to really take advantage of this technology. So now, with 3D Systems, we can make parts that are alloys that you need that have that superior mechanical properties, the fine feature detail that you need, and in all honesty, not in high volumes, as we all know, because CNC manufacturing is still faster for high volumes, but for low volumes and for those where you need ergonomically interesting products printed, you can do it through metal printing today faster than you can with CNC machining. So 3D Systems metal printing process builds up, as we saw in that video, a fully dense, chemically pure, complex metal part from your 3D CAD data by simply melting that fine powder with a laser beam. As you saw, again, it's a very high-powered laser beam, layer by layer. So basically it sweeps the powder over, does the laser beam, sweeps the powder over again. So this really does provide you with that industrial part quality, precision, and repeatability. Today, those printers allow you to print alloys that range from aluminum to stainless steels to titanium and other performance materials. And I'm going to show you some of the different material choices later on in this presentation. With the ability to kind of produce those metal parts with the challenging geometries that I talked about, and if you take a look at these pictures, you're going to see that, that really just cannot be made through your traditional subtractive or even your casting technologies. So DMP, or direct metal printing, is really ideal for aerospace, automotive, and healthcare applications, among some others out there. But it allows for the production of small and extremely complex shapes so that you don't have to worry about tooling. And it really permits you to dramatically different part design than from your conventional process like machining and stamping or even die casting would allow. As I said, we all like to say that additive manufacturing complexity is free, even though it's actually free. So there really is a very little cost or time that's associated with making the parts of a very high geometric complexity. So it's really one of the reasons why 3D printing is being adopted for fabrication of all sorts of performance parts. I just want to give you an example of how companies are using 3D Systems direct metal printing today. So I'm going to go through a couple of these that are listed here. Number one, your conformal cooling channels can be printed within objects like turbine blades and other components that are exposed to extreme temperatures. Those channels are not manufacturable any other way. You can't do that through your traditional CNC, and it really empowers the new designs so that they're lighter and perform better, believe it or not. So speaking of lighter weight, DMP, or direct metal printing, is really great for shaving the weight from parts. Lattice structures, topology, and thinner walls are easy to do with your direct metal printing. So think about how additive manufacturing is perfectly aligned with the weight reduction. Every gram of material that you don't use really does save you time and money. And then of course the opposite is true when you think about it for subtractive machining. We're talking about taking weight out, which really increases your time and cost. From a product reliability, certainly it goes up as things are previously assembled from dozens of components. Now they really can be printed in just one single piece. And that saves a lot of time, reduces bill of materials, and really reduces expenses. So many components are vastly faster to make on a metal printer than complex setup through your CNC traditional machining process. So people have printed those components in a few hours that might take, possibly a month or maybe even more traditionally. And lastly, mass customization, which I'm sure all of you guys might be familiar with, but the ability to print completely customized parts that are tailored for individual customer or patient use really opens up a whole new area in the way of healthcare and consumer products, as well as certainly many other industries as well. So this is just, I wanted to kind of put together a list of where these parts and uses are being made with direct metal printing today, and think about this as far as your organization and see if any of these might apply to you. But many companies really are buying 3D printers for specific uses, and then they find over time that additive is really, manufacturing is really useful in more ways than they actually anticipated once they have it in-house. So as I said, here's certainly many different ways that it's being used today. And if any of you guys want to talk to me about some of these specific ideas and how it applies to you, I am more than happy if you want to send me an email after this to sit down and discuss some of that with you or discuss it with you over the phone. So really, why do you want to choose 3D Systems Direct Metal Printing? Well, here are some key advantages. We have 4 different printers with 2 unique system architectures to address some of the needs. So you don't have to really settle for a non-optimal solution, I guess is what I'm trying to say. Whether you need industry leading precision parts or detail parts or flexible production for your factory floor, either way we've got some of those options that are available. There are other approaches certainly to additive manufacturing. So here's really, I say, some good advantages for 3D printing. 3D Systems offers about 4 different machines out there, and I'm going to talk a little bit about some of these so you guys have an understanding of what the difference is. And they all have different capabilities. The DMP 100, 200, 300 are automated systems. They offer kind of a hands-down great surface finish, and they have 3 different size systems. The build plates are different depending on what size you need for your research and development. And of course we've also got the 320 unit, which is our latest and greatest, and that's built on an architecture that's focused on throughput and production flexibility. Where almost 500,000 parts built, 3D Systems has refined and optimized the printer to run the most challenging of alloys on a 24/7 production environment. So let me just kind of show you a little bit about the ProX 320 and this heavy-duty metal printer and what you can get from this. Obviously, with the 320, you can ramp up your additive manufacturing, print parts with some of the highest performance alloys, such as titanium, stainless steel, or Inconel 718. So with the 320, like I talked about, it's been proven with over hundreds of thousands of prints. This is designed to run 24/7. This has got the largest build volume with a 275 by 275 by 420 micron build volume. So this is really a large build volume. The nice thing about this is it's a good example of a quick swap build module. So this enables you to super fast turnaround builds between material changeovers and fast powder recycling. So as soon as one build is complete, you can remove the entire build module, roll in a new one, and then you can start your next build. So while you're actually removing those parts and you're depowdering those parts outside the printer, as you saw in that video, it's easy to remove, as you can see in the left image there, in the lower left image. So as included, rolling stand kind of lets you move the build modules around your shop floor easily, which means that there's virtually no downtime between those prints, so you can keep the pace and demand production cycles that you kind of expect. In addition, the sealed chamber during the builds helps keep that oxygen contamination to a very minimum, and that's very important when you're talking about building metal parts. So every part that comes off of the DMP, the Direct Metal Print 320, it's really exceptionally chemically pure as well, because of the build chamber that has the low oxygen content of only 25 parts per million. So that is really incredible. So such a low oxygen environment enables that 320 to build in an oxygen reactive alloy that's really challenging to run in other printers. That means that these parts are really strong and corrosion resistant as a result. The 320 actually features build parameters that are developed from an outcome of, like I said, nearly 500,000 builds, and they give you that predictability and repeatability for virtually any type of geometry. As I said before, complexity is really free. So we just came out with this printer at the beginning of 2016, and yet it's still got that decade of over a heavy use and optimization through running it in a Service Bureau environment. So these are the materials. As I said, the 320 actually is available in two configurations. One is optimized for titanium, and one is optimized for stainless steel and Inconel. And these configurations can be changed at any point with a 3D System service technician to simply switch it with a service visit. So those are the three materials that are also most challenging materials that can be run in that 320. So again, the 320 is heavy duty. It's a great standard productivity for metal printing, designed for high precision. And as I said, of course, it's chemically pure titanium, stainless steel, and Inconel parts. Here's a little bit of some of the details so you can see what it is. As I said, it's in this case, if you want it in inches, it's about 10.82 by 10.82 by 16.53 in inches. There's your three different types of materials that are run. It's showing your minimum feature size, also your minimum wall thickness, and your typical accuracy, which is going to be about 1 to 2. It's also got a great recycling system, so it'll recycle any of that unused powder that can be used again if it hasn't already been set up in a part build. So let's go on, and I want to show you a little bit about the ProX 100, 200, and 300, because those are different systems. Again, those are designed for highly functional parts that you can print out in a matter of hours. In addition, the time-saving benefit from all three of these are certainly much more, in some cases, than over CNC machining and investment casting that can be certainly difficult as well. With the ProX 100, 200, 300, it really does allow you to get exceptional detail, and that is automated as well. So you can run cobalt chrome 17.4 in the 100, and the 200 and 300 add the ability to run your marging steel and aluminum products in addition. So the 200, 300 allow you to run a few more materials than what the 100 does. In addition, the 100, as you'll see, is a little bit smaller build chamber. The 100 is about almost a 4 by 4 by 4 versus the 2 and 300, which is a little bit bigger build chamber, and I'll show you that here in a moment. This is a perfect example of a couple of customers that allow you to increase the functionality and design of your products that you were restricted to with CNC machining. If you look at this unit on the left-hand side or even the right, there is no way you could do that with a typical CNC machine and casting. So by being able to do this, first of all, on the left-hand part, they were able to take 5 to 6 different individual parts, combine that into one 3D printed part, so you didn't have the time involved in assembling them. Plus, you're able to create a part that's less weight with thin-walled structures and the complexity. With the DMP 100, 200, 300, they are high density, greater than 99%, thanks to our patented roller layer system. So what happens is during the print process, it will lay down a line of powder, and then the roller will come back and it'll roll over that and compact each layer as it distributes the powder, forcing those particles to close closer together, and it enables you to get higher density. That's something that no other manufacturer has out there, and that's a big advantage to metal printing, and that's what gives it these high densities parts. So clearly you're going to get better high quality castings with uniform properties really throughout that whole build volume. With the 3 printers, they work with the lowest particle sizes and layer sizes of 5 to 30 microns in metal 3D printing, leading you to, again, the ability to get excellent material quality. You're going to get a surface finish of about 5 to 6 RAs, which is really great when it comes to metal printing. In addition to that, you're going to have certainly mechanical stress, limited mechanical stress that's involved, and honestly, these parts you can do anything with when you get them off. They are true end-use parts. They are just as durable as those are produced on your CNC machines. With the increased definition of details, you get a feature resolution of about 150 microns. So when you get ready to remove the parts off this build plate, actually it's easy removal with minimal scarring of the part surface. Typically you're just going to take a wire EDM and you're going to pull those parts off of it. And at that point then you can simply do whatever you want with that. If you need to sand it, whatever you might want to do. So I just want to show you the smallest part detail resolution you can get off of this. This level of detail resolution is really unique among these parts. The small intrinsic parts really can't be built by any competitive DMP. So if you take a look at this, gear with 20 teeth, I mean, look at how small that is, and look at the level that you can get. The C-clamp holds about 16 thou wire. So again, very small details. And the other thing is tolerances are more important when you're building one-off parts, which you're going to be doing typically with metal. When it comes to manufacturing, repeatability is really the key though. Customers are used to that excellence of repeatability in your CNC machining. And so with the 3D Systems direct metal print process, it's consistent and it's repeatable, and to produce those prototypes, but also for direct manufactured metal parts. From the repeatability standpoint, really the ProX direct metal printers offer that repeat result. And that's because 3D Systems manufactures its own process optimized scan heads, the precise mechanics, the motors, the precision optics, and the mirrors. So other printers can't make all and control those parameters as well as we can due to the patented roller system that I talked to you guys about. from tolerances, the first time build tolerances are about 50 to 100 microns on most dimensions. And then better tolerances are achieved for some of those repeat builds that actually can be fine-tuned. And again, along with it, of course, you're going to get the software that comes right along with the 3D printers. So you can specifically set it up for material and part-specific settings and buildings. You can optimize the supports. It's going to use the actual powder itself for some of the support structure. So you've got limited use intervention that's required with the software that comes along with the actual printer itself. So really this, again, just allows you to reduce your time in manufacturing, gain some flexibility, benefit from a large choice of materials. Up to 15 different materials are available in the 3D printing technology for metals. So it really gives you a lot of high variance there for different types of metal solutions. And again, I'm happy to go through or provide you with any detail on any one of these units if you guys have any questions at all. And I'm hoping that this has been beneficial for you. I just wanted to give you enough information to show you what 3D metal printing can do today. So please don't hesitate, to reach out to me if you have any questions. Here's the build volume that I wanted you guys to see for each of the 3 printers in the 100, 200, 300 line. Again, the 100 is almost a 4x4x4, the 200 is almost a 6x6x5, and the 300 is almost a 10-inch by 10-inch by 13-inch. As you can see, there's a different laser power with each one of those. Certainly the 200 and 300 have a much stronger laser power. As far as loading the material, the 100 is manual, but the 200 is a semi-automatic, and the 300 is a fully automatic for loading the material. You don't have anything that you have to do. It's automatically loaded. Same thing with the recycling. The 300 has an automatic recycling system to recycle any of that and capture any of that unused powder that hasn't been used. And then the 200 has an optional external system as well as the 100. And of course the build plates on these obviously are metal, and they're including all of these. So I hope that that has given you a little bit of information. Happy to answer any questions for you later. Please feel free to contact D3 Technologies if you want to talk about anything further. And thanks so much for your time. Appreciate it. Have a great day. Have a great rest of the weekend.